So good evening, guys. Hope all of you are fine. Welcome to the session 2 of CeLeLe 1 3 practical. So first of all, I would like to say sorry to some of you for I not replied to some of your uh, chats that you sent to me on MS Teams. Uh, that I did intentionally because firstly you you need to come out of that arena now that uh, you will have a doubt and you will directly ask uh, and we will tell you directly. Spoon feeding will not be the case here at all. So firstly you have to approach your friends because I see most of your doubts are almost similar and I replied to some of you and you guys are not passing on. That means you are not well connected amongst each other, right? So that should not be the case. For to avoid that confusion, to increase your connectivity, we shall take some initiative. Like we'll introduce one more channel in this MS Teams platform, which would encourage which we would encourage you to put your doubts in, and anyone in your community among 150 students registered in the course can answer those doubts. Or if if anyone is not able to answer, then we would of course answer, but we would answer to the unique doubts. We will not answer to the same doubt again and again, right? So we'll answer to the only the doubt which have 20 or 20 or 10 likes, like thumbs up, because we feel that uh, if that is not the number of persons who have the same similar doubt, then you have not approached anyone to solve that problem. So if you are not going to help yourself, no one is going to help yourself. So uh, ask to ask firstly among your friends. If nobody knows, then approach to us, and uh, do, approach to us on the platform, and don't spam the personal messages, uh, right? So this is the second tutorial. So let's begin it. So for those of you who has doubt, don't worry. I have taken your doubts into account, and like some most of you had doubt in some codes or some reports. So I'll take care while evaluating that. Uh, Particularly, I've taken your name and your doubt, and so I'll take care while evaluating that it does not come into your evaluation, right? So let's begin with today's tutorial. Hello, am I audible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So how many of you know what is Gauss elimination? Like, I suppose everyone have done MTL 101 at least, if not seen the lecture of Gauss elimination for this course. So, how many of you have done MTL 101? Just raise your hands through the raise hand button. I should see all of you to raise your hand. If you don't raise your hand, it means you are not there. Okay. So, Soumya Bharti, so can you tell us what is Gauss elimination?
Hello,
Yeah,
is my voice?
your voice is breaking, I think. So, someone else would like to volunteer for telling what is Gauss elimination?
Hello, sir. Should I?
Yeah. Yeah, yes, okay, go ahead.
Uh, Sir, I was going through one web page. Can I share the screen? Means there is matrix, so it would be easy to explain.
So can you tell the metrics for us?
Yes,
Uh,
sir, sure. Um, it it is an augmented matrix. Uh,
okay, you share your screen. No, no issues. I
okay, okay, sir.
share.
Yeah, is it visible?
Yeah, it is visible.
So, in Gauss elimination, what we do is we'll look here. So first of all, we find the pivot position. For pivot position, we see, so here this is the largest element. So we swap first row with this. So after swapping, we have like this, and with the help of this element, we make all the terms below it as zero. Like we can multiply this with 0.02, and we can subtract with this row. So after that, we have matrix like this. Then we come here and we look for the pivot position. If this is zero, then we look for a non-zero element. If there is no non-zero element, means here there is no pivot element, but here we have a non-zero elements. We look for the largest one, and we swap these two rows. So we have this row here. Afterwards, same method we do. We make all the elements below them as zero. So we will have something like this. Afterwards we will have something like this. Same we can do for here. We can find the pivot position here. 100, we will swap these two rows. We will take 100 upside, and then using this as pivot position, we will do, we will make this zero. And after making this as uh, upper diagonal matrix, we can means again make these equations, and we can solve for this x4, and then back substitute and find x3, x2, and x1.
Okay, okay. So that was perfectly fine. Okay, okay, good. Now
Thank you.
let me again share my screen. So so we so Takir explained us how to do Gauss elimination, right? So I would now try to explain you why do you need Gauss elimination. So suppose there is a matrix. We take a two by two matrix, one, two, three, four, and why in the world you want to do a process called Gauss elimination? Can someone answer that? Why do we want to
So
do
it
Gauss elimination? Yeah.
reduces the complexity into, like, it reduces the number of operations we need to do in order to calculate a determinant or something of that sort, or solve the equations.
Yeah. Yes. Exactly. Yeah. Someone else wants to answer?
Yes, the previous person said, it reduces the time complexity also. And suppose there are a lot of equations, like we can manually solve two, three equations, but if there are four, five, six, seven, eight, nine, so this method would make it easier to solve.
Okay. Right. So what in this Gauss elimination we do is uh, to solve the equation, but here only a matrix is given. So what Gauss elimination do is it converts this matrix into either a upper triangular matrix, uh, upper triangular or lower triangular, or we can convert it into a identity matrix. Right. Right. Basically, by applying the operations, we can convert it into a lower triangular matrix or upper triangular matrix. That is, upper triangular means we have only elements in the upper triangle, and the rest of elements in the lower triangle are zero. In this triangle, are all the elements are zero. So this is 2 by 2. If there is 3 by 3 matrix, suppose 1, 2, 3, 4, 5, 6, 7, 8, 9, and suppose there is this. So this is converted into this, and this all elements become zero. So this is a upper triangle matrix, and upper one is a lower triangular matrix. So we have to apply a set of operations like plus, minus, addition, plus, minus, multiplication, and division. Pardon me. So by applying these operations, we have to convert this matrix into a upper triangular matrix or lower triangular matrix. If we convert it into a identity matrix, then the method has some other name called Gauss-Jordan. We'll come to that in our second question. Now, firstly, we are doing our first question, right? So, how can I convert this element? Uh, like I have to convert all the elements below it as zero. So, how can I convert it? What operations do I need to apply?
So we will
Can-
apply elementary row operations. Like
okay,
firstly, we can write R2 goes to R2 minus 4R1.
okay,
So that will make the first term as 0.
oh, nice. Uh, 4R1. So, can someone fastly calculate and tell me?
-6.
6, 7 minus 4 times 3 is 2.
So
Will
what
be
our
Then
operation is
S1
R2 minus.
yeah,
is
Oh
so
no, you're not.
7 is
R3 also. R3 minus 4R1. 7R1.
7R1.
So what we are doing, we are applying the operation, firstly operation to do a first column as 0, then will second, this is one thing, and here will be there will be some elements which you can calculate, and then we'll apply another set of operations where this element we will make 0 by this. Subtract R3 goes to R3 minus some constant into R2. Is everyone with me in that? On this matrix, we'll apply this. R3 goes to R3 minus some constant times R2, so that this becomes 0. Is everyone with me till now?
Yes, sir.
So, so after that, we'll get some uh, upper triangular matrix. We'll, we'll, we'll have some elements 1, 2, 3, say 0, x1, x2, 0, 0. Some some element will be there. Suppose this 3 is there. Uh, so this what we get by Gauss elimination. Now, what is important to us and what is significant to us is solving system of linear equation. Our ultimate target is solving a system of linear equations. Right? So with these three, suppose there are three equations. So this will be a matrix will be there on this side. A times x is equals to b, where b will be a vector of suppose 3 cross 1 vector, and x will also be a 3 cross 1 vector, and a will be a 3 cross 3 matrix, 3 cross 3 matrix, and there will be some variables here in the x. suppose they are x1, x2, x3, and after when we apply operations to this, we apply row operations here, so we apply similar row operations here. uh, Gauss elimination is basically the elimination method which you used to do in when there were two equations, right? Suppose 2a plus b equals to 3, and a plus 2b equals to 3 is there. So these are the same operate. Now what we do? Suppose we have to find out something. So we multiply it by 2 and we'll subtract. So what we are basically doing is that we are applying row operations on this row. In the second row we are applying a row operation. In the when it get complicated like bigger matrices, so it is not possible for us to apply elimination method on such n cross n matrix. So for that we need this Gauss elimination method so that our work can be automated. Okay, so after we have done the Gauss elimination part, so there will be some elements a11, a12, a13, a21, a sorry 22, a23, and a33 is here. 0, 0, 0, b1, b2, b3 is here, right? So after back substitute the values. So suppose we start from the bottom, and we multiply it here, then multiply it here. So a3x3 is equals to b3. So and then we make a a22 x2 plus a23 x3 is equals to b2. So that's how we write back substitution equation, and uh, then solve then solve this. So basic steps of Gauss elimination that we have. What are the basic steps? One thing are elementary row operation. Operations till you get a upper triangular matrix. To get upper triangular matrix, so that you are able to back substitute easily. So why this is called back substitution? So suppose you find from here you get x3 easily, then from here you can get x2 from here, then you know x2 and x3 from here. So next equation you get x1. So x1, x2, x3 are known, and your problem is solved, right? So that's how this method works. So what the basic thing in this is some in its implementation are that we can when there is n cross n, like in 3 cross 3 we can apply row operations by hand. But when there are many like n cross n matrix, then we cannot apply it by hand, and we have to resort to some uh, computer program which help us to automate our process of doing this. So So here ma'am have taken the example of elimination and have explained it in the lecture. I was just reiterating for those who might not have seen the lecture. So uh, so basically in this there there is a equation recursive that you have to apply again. Yeah. So this is the fundamental equation of this Gauss elimination. So what you are doing is that each time you have n cross n, a11, a12 up till a1n, a21, a22, a2n till an1, an2 up till an. And suppose you have to apply Gauss elimination in this. So how you will apply? So you have to do, firstly you will apply n minus 1 operations on this. N minus 1 row operation firstly. So how will you apply that? You will set a pivot element. You will take this is pivot element, and you have to do all the things here zero as zero, right? So what you will do, that suppose akk is your pivot element. So you will divide that every element of that column. This is a factor uh, with which you have to what you have to normalize your whole row with this factor, like a21 by a11. You have to normalize it. Are you all getting it? Hello?
Sir, I have a doubt.
Yeah, yeah.
If A11 is 0, then we will swap this row with some another row.
Yes.
So, which row means the row in which means we will as we go down. So, the largest element or the first non-zero element we get.
So I'm coming to that talker. I'm just telling plain vanilla Gauss elimination now. So that is a problem when it comes. So we apply a special technique called partial pivoting, which is your first question. So in that, what we do is uh, apply we take the largest element in that column after this. Like suppose a11 is here is 0. So we will search for a largest element in this row, in this column for a11, and with the largest element we swap the first element. Are you getting it? We will swap whole row.
Yes.
Okay. So so does anyone have any doubt in this formula? Hello. What does this formula tells us? We write it. Lg equals. What does this k minus 1 shows? Can someone tell what does this k signify?
The iteration number.
Yeah, yeah. You are step by after one iteration. You are choosing your pivot. So suppose you have chosen your pivot to be a11, then your k is 1. You have chosen secondly you will choose your pivot to be a22, then your k is 2, uh, and so on. Suppose akk you are choosing as your pivot, then so this is k. So these so we are updating the values of this uh, of whole row, or the yeah of whole row. We are updating the value. So this is the value of aij in the previous iteration, and how we are updating it, that's what is written here. Aik k minus 1. So suppose if we take 1 1, we put 1 1 in this, so nothing will happen. A11 in the, suppose in the second iteration we are taking it, and from the first iteration we know. So let me take 2 1, 2 1 here, 2 1. And suppose for the first iteration we know the value of A21. So A2 K. So what should I take the value of K? 2, 2 of course. So let me take it to be as to, this is not the correct example. Sorry, I'm sorry. Uh, Let me take some another example like a A23. I should take A23 will not be zero in this case because A21 after the first iteration will be zero. In the when you'll do the first iteration, then it will become zero. First iteration means I mean zeroth iteration when you'll do like when these are original. So this A21 will itself become zero in that scenario. And if you are confused, don't worry, you'll understand it when you go through it once, right? So let me take 2 3 A23. You know the first after the first iteration, what is the value? So I've taken the pivot to be this element. So minus this is pivot element. So we take the pivot and and then I is 2, then K is 2. Yeah. So by this element only I will normalize it. As I said, this is the normalizing factor, and now will modify this. That's how it will get modified. Okay, so basically you can see here there will be three loops going on: T, I, J, and K. All of you know about Einstein convention in CLL 1110. You did you study
Yes, sir.
Einstein convention? So do you know about free indices? What are free indices?
Yes, sir.
So what are free indices? Tell me.
Means in an expression, they repeat twice. I mean, and they have a summation. They have a summation from 1 to 3.
Yeah, summation from 1 to 3. So here IJK are free indices. They are moving from 0 to n. Suppose K is moving from 0 to n, 0 to n minus 1. Then I and J will move from K plus 1 to n minus 1. These all things are written in your slides. You can go through them. Like for any general step K, what formula you have to apply. And there will be basically three loops, uh, three loops going on. So as you know, the three loops are going on by three uh, n times. N times at most n times they can go. So the time complexity becomes n cube in their three loops. So this is the back substitution. Uh, then after you have found out the upper triangular matrix for this, then you have to find the what is the n solution. You have to find the solution. So you start from the last. From the last element you start and going upwards, you find other elements. So once this xm is known, then xm minus 1 is known. Uh, then other thing is known. So that's what relation is given here. So you start from the nth, then you go from n minus 1, n minus 2, n minus 3, and up till 1, and you get all the values. So now I'll come on partial pivoting. Why you need partial pivoting is, like, here in the formula you can see that AK, AKK is there. So suppose this AKK is a very small number or 0, what you'll do? Then this will shoot to infinity, minus infinity, and your coefficients will be very skewed. Then what you'll do? What is the solution to it? Would someone like to answer this? How can we escape from this, from being it to be a very small number, or a very, or 0 itself? Can someone tell? Hello, am I audible? Hello.
Yes,
Yes,
sir, you're audible.
yes.
So would you like to answer? So I have already told to talk is out what we have to do. I would reiterate it for you that what we will do is we'll take the largest element. Suppose we are taking a kth pivot, AKK element as pivot, and we are applying Gauss elimination after taking AKK element as pivot. And suppose upon our encounter we found AKK to be 0, 0 or very small number. So what we do is we have checked all over this. We do not need to take in this. Now we'll see below it only. We'll check for the element which is the largest in this column, and we'll swap the whole row. Suppose we find the jth element, ith element to be largest in this. AIK is the largest element in this column after AKK, right? So we'll swap the whole ith row with kth row. And how to do that swapping? The pseudocode have already been provided in your lecture. You can refer to it. Like, I will show you when I have provided the pseudocode for this. So you have to start with certain index of the kth row, that is the pivot row, and then you have to find the biggest element. And if you find the biggest element, and then you have to swap whole row with that. If that is not that element itself, then you have to do that. Hope I'm clear on this. Yes or no? Should I repeat any step?
No, sir.
So I recommend you to try coding it yourself. And suppose, let's say 20 minutes, you try to code cross elimination. And should you have any difficulty, uh, please let me know. We are here to solve it. Because once you solve this basic cross elimination, that you how you have to do, then every variation of it, like Gauss Jordan, uh, and this partial pivoting, these are all only one or two lines ahead here and there, and you are all done with your assignment. So If you do first question with very much high understanding, then second question is only 5 to 10 minutes game. Okay, so understand it thoroughly. First question, then second question. I'll tell you how what to do. So you just write and let me know should you have any doubt. You have time till 6.
Excuse me, sir.
Yes,
Sir,
go ahead.
you just said in the chat that we have to take input from the text file. So, what is the need for that? Means, can't we just take input from scanfn?
So uh, when you take input from scanf, then you have to apply the input you have to write the input every time. So how we will run your code and test it? Uh,
Sorry, sir, can you repeat? Your voice is a bit cracking.
yeah, yeah. It is not a issue at your end, but it is a issue at our end because we have to evaluate your codes, right? We have to evaluate lots of codes, 150 codes. Then how if we will give input every time by our hand, then how are we going to check it? So if you will have a input file
Okay,
and output file, then we'll check your input and output file and evaluate on the basis of that. Hope that is clear now.
okay, sir.
So when will we have our vivas or when will they start?
So Vaishali, we are planning to start it from this weekend. So you will be having a Viva on this weekend. So those who all will be having a Viva will be informed prior a day that you are having a Viva at this particular time. So you join the Google Meet link for the Viva and the give a Viva and get get yourself created the pieces.
Okay,
Okay.
okay, sir. So we'll be informed by email or on Teams.
Uh, on email you will be informed like email will be sent to whole class so you'll be able to see whose turn it is. So that your if you might not check your mail so that your friend can tell you that today is your turn for sure.
Okay, sure, sir. Thank you so much.
So anybody do not have any problem in writing the code for Gauss elimination. Should I consider this yes or no? Okay, we shall move forward. So what is this is the this was first question in which you have to do a program. You have to write a program of Gauss elimination with partial pivoting, which I think is clear to most of you since you are not asking them. I hope it's clear. So now comes Gauss Jordan elimination. So we'll refer to lecture now so that you have coherence better than when you refer to it. So what in Gauss Jordan we do that in Gauss elimination we are creating a upper triangular matrix, right? So in Gauss Jordan method, instead of a upper triangular matrix, we create a identity matrix. So you can see here the identity matrix is created in this by apply first making this as 1 uh, and then all the elements below it as 0. Then we take pivot as 7 and elements other than 7 we'll first make 7 to be 0 1, then other elements to be 0 with respect to 1, and so on. We apply all the operations and we finally get an identity matrix, and we apply similar operations on the right hand side, like the equation was ax plus b, right? What I showed to you here, ax equals to b. So the correct the operations which you apply to a you apply to b. So a inverse it automatically get multiplied uh, with its inverse, and like we get a b as the our solution, because this become an identity matrix, and identity matrix times x is equals to that variable x only, and on the right hand side we get a solution b1 b2 b3, like modified b1 b2 b3. Now how this is useful, uh, not only it is another version of Gauss elimination, but it is a method to find out the inverse of a matrix. So suppose you have matrix A. Let me show you how. Okay. So you had this matrix, right? A matrix you had, and you want to find its inverse. So you write A times, suppose B matrix is its inverse. So A times B equals to I. You write it that way. So A times B equals to I. Then so that's how you're writing this. you this is A matrix, and this is some identity matrix here, or you can consider it as like A B equals to I, where B is your whole that matrix, the inverse matrix of A. So you apply the Gauss elimination on with respect to this the first three elements only, like with respect to A matrix, and you apply the corresponding changes on the right hand side to this also, to the identity matrix. So when you will make this is the A matrix is identity matrix by Gauss Jordan elimination, on the right hand side what you'll get is the inverse matrix. How now the A matrix have been converted the uh, into the identity matrix, and on the and I times B is equals to some matrix. So I times B is B. So you have found out the inverse. So that's how you find out the inverse using the Gauss-Jordan method. So should I repeat it or is it clear?
Sir, please repeat it just once. The inverse.
Okay, one minute, I'm repeating. See, what I was saying is that you write it. Uh, Now you have to find the inverse. Now your problem is to find the inverse. AB is equals to I. Inverse of A you have to find, and you suppose your inverse to be as B. B is equals to inverse of A. You have to find what is B. So you apply a, a Gauss Jordan elimination on A, and you have matrix here and here as 1 1 and the rest all 0 here and 0 here. So you apply Gauss Jordan elimination on this and make it into a identity matrix. So you will eventually convert it into identity matrix like this. So you have 0 here and 0 here. So and you'll get some matrix here. Suppose M, whole matrix I'm telling it as M. You get here. So B times identity matrix is B. B only. So the M matrix that you have got is your inverse matrix. Is it clear now?
Yes, sir.
So what is the difference between operations that we are applying in Gauss elimination and this Gauss Jordan? Can someone tell what is the basic difference in the operations that we are applying in this and that?
In this method, we first normalize the pivot element.
Yes, first difference is we pivot to normalization of pivot. What other thing?
Also, we have to go above the elements and make all those also zero to make the identity.
That in the Gauss elimination methods, we are only taking the upper triangular matrix and not making these elements as zero here. And we are making in the Gauss elimination, we are not making it to be zero. While in the uh, in this the Gauss Jordan method, we do we apply on both sides, bottom also and up also. But we do not apply those operation on that particular array that we are considering. So hope this is clear now. Anyone have any kind of doubt? So you will be able to do the part one of this, right? Gauss.
Sir, I have a doubt in the code while writing the code. Can I share my screen?
Yes, yes.
Is it visible? Hello?
Yes, it is visible.
I just wanted to ask that I imported these three libraries, but I was getting some sort of error in this expression here. It is saying that it is expecting an expression, but I think there's nothing wrong with it. Here's the term that has to be updated, and here is the coefficient that has to be divided and multiplied by this one.
Mm,
So is there any library problem or anything else?
are you sure you are writing it correctly, the expression correctly?
Yes, sir. I think there's nothing wrong.
Like
Hmm.
I plus one, you have written I plus one. I I think there should be I and K. There should be.
But
Okay,
sir,
see,
here though we have to write a constant, right? To multiply with row one above row, so that we can update the below row.
yes, yes, you have to do that. You once check the relation. What is the relation?
But sir, it's to my wish, na my expression. At least the expression
Yeah,
should be correct in the code, right?
yes, yes, it should be correct. Uh, so you are doing a error of parenthesis. Have you checked the parenthesis error is not there?
Yes, sir. Parentheses are correct. They are differently colored, and I think.
Uh, don't put this parenthesis. Try to remove this parenthesis starting and from here also.
I think we are missing the semicolon too. Somewhere.
Yes, but it's saying that semicolon is missing. Where? On this line only, it is saying that semicolon is missing.
You have you in a I plus one k. You are putting extra parenthesis. So try to remove that.
Uh, what, sir? Delete this one.
Yeah. Not this. Not this. It's still showing.
Uh, I'm not able to hear you, sir.
Yeah, it is still showing that.
Hmm. I think I can do it in C, but I was starting to use C++ and I don't know exactly how to resolve this.
Right. In my opinion, there should not have been this problem. Uh, after the class, we'll see. Okay.
Acha, okay, sir.
Okay.
Also, sir, that dynamic 2D array one doubt that was, I think,
So
forgotten to be resolved in last class.
yes. I'll resolve that also.
Actually, Mohit sir had shared a link for this dynamic array doubt only. So you can check in session 2 chat. There's this link. I'll share it here.
So anyone have any other doubt in the assignment? Ayush, you can check the chat box.
Acha, okay, sir. Also, sir, can you explain once again what exactly has to be done in the report? Because this time it was a lot of, I mean, it was not, I didn't exactly know what was to be written, so I wrote whatever I felt like. So, can you again tell the exact format of the report?
Yes. So in report, what you have to do is basically first thing you have to write your approach of solving the problem. What you are thinking while, while solving the problem. First thing is approach. Second thing is what you are like in this assignment. There is no error and all those things. Uh, so no issues in this. So uh, for for this part, you do not have to write all of the after every iteration what values you are getting. You do not need to include that. But for one or two iterations, you can do like in suppose 10 iterations are happening. So one or two iteration values you show in between, and you can comment on your final answers what you are getting. That is the third part. You have to comment on whatever you are getting. You are solving the answer not just for the sake of solving it, but uh, like at this level, we should be able to comment on what we are getting and why we are getting so, and related to the theory, how you are relating your programming. Like programming is one thing and theory is one thing. So you have to relate how your programming is relevant and coherent with the with your coding what you have done to get the answer. So that's what you have to do in the report. See, report is kind of a open-ended thing. So if it is closed-ended, then everyone will make same kind of report and submit. So that's why it is a kind of open-ended thing. So the better you can think about any comment or any observation that you made while running your code, the better it is. That's why it's a kind of open-ended thing. But bare minimum things, these things we see that what you have written. First is approach. Second is what are observations you are having. Some iteration is uh, like suppose you are the first person to start the Gauss elimination. Gauss elimination like you are starting with naive Gauss elimination, and you observe that there is some problem in this. So you have to, yeah, and then there was another method introduced like partial uh, partial pivoting applied to that, and that helped uh, solve the problem to much extent. So that's how these things are made. So I am not saying you have to do a new thing in your reports, but just write whatever you are observing, if that makes sense. Hope it is clear now.
Acha, okay. And sir, if there is a lot of data, then we can include a graph. If there is not a lot of data, then there is no need, right?
Uh, if yeah, if there is not a lot of data, and if you are plotting a graph, then it is always good. But in this assignment, there is no need to plot the graph. What thing you will plot the graph? So in this assignment, no need to plot the graph. For the assignments in which errors are there, some tolerance value is there, there you have to make the graph to show that your value is actually converging or not, uh, and so on. It is clear.
Yes.
So yes, Tejas, you have some doubt.
Yes, sir. Sir, actually, I'm working on the code, but suddenly I strike that one doubt of the previous assignment. It's just a simple, it's a trivial thing. Can I ask that?
Yeah, yeah. Yes.
So in the third question, it was given epsilon TOL. This we have considered as the tolerance, but is it the percent or it's the absolute value? because I have considered it as an absolute 10 power minus 6.
Okay.
So, but if you take it as a percent, then you will get some more values. The output will print the some 2 to 3 values more. But if you have
Uh,
not taken,
so you have written that you have taken it percent.
no, I have just yeah, I have in the comment section I have just written it as a tolerance value. I have not written that that is it a percent.
In the report you have written, you have to write it somewhere, right? How can I understand that you
No,
have taken it
means
there?
I have not written that it is percent. I have just said I have mentioned that in comment that it is a tolerance level. That's it. I have not written it as a percent, and I have not
Okay.
taken also. I have taken just absolute 10 power minus 6.
Then it is fine, perfectly fine. Issues fine. It was not percent, it was absolute number.
Okay, okay. Thank you, sir.
Yeah. Yep. So your name is Franklin, right? The one who have wrote in the chat box. Can you just speak up?
Yes, sir.
Yeah. So Franklin, can you please tell a specific doubt that you are facing in augmented metrics?
So that slide where you were showing about the augmented matrix and how it transforms to that what was written in the second question. So how after performing the Gauss-Jordan steps we get identity X inverse matrix. Can you please explain that part again, sir?
Okay, okay. So uh, you understand the Gauss Jordan part of the of this thing, right? That how to apply the Gauss Jordan
Yes,
elimination
sir.
matrix. You understand that? So when you are applying the row operations in this A matrix, you have to apply similar row operations in this identity matrix so that it gets transformed. Are you getting this?
Yes, sir.
So when you apply the similar row operations, so this will also become uh, this will become the inverse of it. So let me show how they have written. This way of writing is different. So this is the A matrix and this is the identity matrix. So if you do not augment it like this also, like making a whole big matrix, rather than that you can take both as separate and apply the operations on it. But the operation which are to be applied on this should be applied on identity matrix one to one. Like it should not be that done that you are applying the Gauss element Gauss Jordan separately on both the matrices. That would not help. You have whatever you are applying on this A matrix, you have to apply on this, not independently on this. By independently, I mean like you cannot do like you are transposing the second to be this 0 minus 1 by 0 minus 1 by 1, whatever it is. Like you cannot do it like this. The operation, like here you will apply zero point 0.1 minus zero point 0.1 by 3 times something value. So here you will not apply this. Are you getting it?
Yes, sir.
So that's how. Is it clear now? Or
Yes, sir. Thank you, sir.
so anyone have any other doubt?
Sir, how do we have to take input from text file?
Hmm. Manchi, you have to Google. You can Google it. It will be available on the
Uh,
Geeks for Geeks.
coding, coding part, so sir, I did
Okay.
in 12th standard. Like in text file, what will we have to? We have to make variables with that values.
Yes, you have to take input one by one. Like for the you have to take a stream of input. You can apply a for loop in that for loop or a while loop, like while end of file. You have to take the input from the file and store it in a variable. You have to predefine a matrix, like matrix A, where you'll take in the values of A only. Then like you cannot write in any order in the text file also. You have to write in a particular order, particular things, and then take the input. So I think it would not be a problem. Once you see how to take a input from the file, then it will automatically run in your mind that how you have to place it in the input file, that it comes in a right way. So it depends on you that how you are putting it in the input file. There's no restriction to it as to how you input in input file, but it should be read from an input file. That is the only condition. Is it clear? Uh,
So, sir, can't we assign the values in the program code itself?
so it's so if you assign the values in the program code itself, then it cannot be changed later on. It will be very difficult for you to change. Like once checking will be done, you'll have to give your Viva also, and in Viva we might give you some other values on which you have to run your code. So
So,
if yeah,
sir, there's an option like if we request input from the user every time the program runs, then that would be better if so.
so see there are two problems in this. Na, you're not understanding that. Yeah. So if you ask user to input, then how you will evaluate 150 codes? We, we will need to type it every time we are starting. So we'll type 1, 2, 3, 4, 5, 6 for the A matrix. Then for the B vector, we have to type it again and again. So that method is completely eliminated. Now you will say that you will write it in the that only, but I'm saying that like it might look nice now, but if if you are doing it again and like if some value is changed, so some value is tweaked, then there will be a lot of problem if you have written it in that only. Your actual code should not be deformed in any manner. So keep that in mind. So these are some standard practices that should be maintained, and we will maintain. Hope that is not an issue.
Okay, sir.
Anyone have any doubt now?
Hello, sir. I just want to ask a small thing that while we were learning C, there was we would create some input files, and there was a command that we can directly feed the input, and it would take just like a user entered. So is it not like that something in C++ also? Like the name of the executable file in greater than sign and then the name of the file.
Yes, but yes, there is similar command only in C++. Once you Google it, then you will easily find it.
Okay, sir. So we have to provide the input so that you give that command, or we have to provide in the codes so that it automatically extracts.
You have to write. You have to extract it from those files. You have to write them.
Acha, so we have to include the input file along with it.
Yeah, yes. You have to include the input file along with it. So, I'll repeat what you have to submit in this, like two files for that codes for the two questions, and there's one input and one output text file for each code, and also the report. So total how many files? Four, two, one, seven files. Seven files you have to submit in a zip folder. Go to
And
the
then
screen.
uh,
Yeah.
you have to uh, output the results in a separate output text file also. Your output should not be in the terminal or in like your input file. There should be an output file too. Okay.
Okay, ma'am.
If anyone do not have any doubt, then let us call it a day. So I think you do not have any doubt. So we'll close at 6:35. Okay.
Thank you, sir. Thank you, ma'am.
Okay then. Let's call it a day.
Thank you,
And
sir. Thank you, ma'am.